In the 1880s, we saw the introduction of three-phase AC power. Now, this was a marvelous invention by the great scientist Nikola Tesla, and running on that three-phase power was Tesla's three-phase AC motor. Now, this was a fabulous invention. It was the greatest labor-saving device in the history of mankind and changed our lives forever. But it had one significant drawback, and that was it could only run at one speed. So we've come up with many devices and inventions in order to compensate for that basic deficiency. Things such as belts and pulleys and sheaves. Things such as dampers and inlet guide vanes, eddy current couplings, fluid couplings, and so on, all to compensate for a motor that could only run at one speed. Well, it took us 100 years to come up with a device that could reliably and cost-effectively cause an AC motor to run at different speeds. Finally, in the 1980s, we saw that introduction of the variable frequency drive, or VFD. Now, I'd like to look at a schematic of a VFD. If you look at the schematic in front of you, you will see three arrow-looking devices on the left. These arrow-looking devices in the electrical world are called diodes. In the mechanical world, in the plumbing world, we might think of these as check valves. They basically let current flow in only one direction, that is, the direction of the arrows. So we have an AC to DC converter, or just converter for short. This converts the three-phase AC power to DC. Now, the DC that comes out of this is rather choppy and not very smooth, so we put in a capacitor in order to clean that DC up. A capacitor is like a reservoir in a plumbing circuit, and that reservoir smooths everything out and gives us a nice clean DC. Then going to the right, we see 6 switches. These 6 switches compose the DC to AC inverter, or just inverter for short. So by switching these switches on and off, we can create any frequency that we like, and that frequency will regulate the speed that the motor goes. So this entire circuit is called a variable frequency drive. If you hear terms such as variable speed drive, adjustable frequency drive, variator, adjustable frequency AC drive, all of these are just synonyms for the variable frequency drive. Now let's take a look at an actual variable frequency drive. The variable frequency drive that you're looking at was manufactured in the 1980s. You'll see that there is a lot of spare space in this drive. So we weren't packaging it in the small packages that we see now. However, the basic topology of a variable frequency drive has not changed since 1980, over the last 30 years, really the late 80s. Now, if you look at a modern drive, you will have exactly these same parts, but they will be in a smaller enclosure with less space, packed together and many times stacked on top of one another. We come in down here with three-phase AC, and this block that you see right there is the AC to DC converter, or the diode block. There are 6 diodes in there, and they convert the AC to DC. Then we come up here. These 2 blue cylinders are called capacitors. These are electrolytic capacitors that smooth out that DC. Going from these capacitors over here, we have the transistors. So there are 3 transistor blocks here. In each transistor block, we have 2 transistors, and they switch on and off, and thus create a frequency that allows us to regulate the speed of the motor. This has tremendous potential for energy savings and allows us to adjust the speeds of our fans or our conveyors or our process control systems.